All right. Hello, everyone. I'm Dr. Yu from IvyMax. So today we're going to review the AMC 10A and 12A in January 30th, 2020. So I know some of you already took that either one of that test, and you know the B days will be giving in February 5th, will be the day after tomorrow. So hopefully this review will help you to prepare the next AMC test. Okay, here is some statistic I made about the type of questions in the 10A and 12As. So you can see from the bar, the pie chart. So for 10A, the AMC 10, so totally they have 11 the algebra or the arithmetic type of questions. So we take a big chunk of the total amount. And they have 4 geometry questions. And also they have totally 6 of combinatorics problems, including the counting problem and the probabilities. And also they have 4 of the number theorem problem. Comparing to that, for the 12, so they have totally 7 algebra questions, and well, you can see that they have totally 8 geometry questions. That is almost double the amount of 10s this year. And as well, they have 4 combinatorics problem and only 1 number theorem this year. And also they have 5, I call this the ones, the algebra function, including the trigonometry functions, the complex number, and the logarithm type of functions. So that is the 12 only type. So hopefully this is the thread of the A, the test in the A days. Hopefully you can use that as the reference for your preparation for the B days test. Okay, so today I'm going to review based on the category. I'm not going to review the question one by one, but I will just categorize them in this way. So let's starting from the algebra or arithmetic problem. Okay, so here is 4 questions in 10A. Will be the very beginnings questions. So you know that all the AMC question is like the order of difficulty, right? So at the beginning it should be pretty easy, like this, okay? And at the end they will be very challenging. So if we want to be invited to the next round, the any level, so for 10, so you already, generally speaking, you should get 120 out of 150, something like that. So if you count 1 correct question, 6 points, and 1 unanswered question is 1.5, and if you miss 1, just 0. So in that case, you need to make 18, or I say 19 questions correctly. So for the first 20 questions, just you guys see that. So you don't have too many of the tolerance of errors you can make, especially the first 10 questions. So you need to answer those questions fast and correctly. Okay. So I will just go over that type of question pretty fast. Like the first type, so will be the equation of linear equation, right? So we just solve it, and the answer will be pretty easy. E. I try to, oops, sorry. Okay. Okay, first one, E, I just marked it on the screen. And second question, also pretty easy. So the number of, they give you 5 number and have a average of 15, and what is the average of A and B, right? So average, so equal to the sum of the numbers divided by the total amount of numbers, right? So in other words, the sum of a series of numbers should be the what? How many number totally multiply the average, right? So this question is also pretty easy. Answer is C. Sum them up, you got the total sum, minus 3, minus 5, minus 7, and you got the sum of A and B. Divide by 2 is the average. Okay, third one. Okay, this one, you can actually answer the question in second, right? So you can find out that we can get 3 of -1 doing the product, right? So 5 minus C in the denominators and the C minus 5 in the numerators, it can cancel out, leave a -1 left, right? So like that, -1. So you can repeat that process, and the answer obviously is A. Very easy. Okay, number 5 in 10A. So this is also very standard, the quadratic equations, right? And the absolute values equations. So we can rewrite that into 2 types. So x squared minus 12x plus 34 either equal to positive 2 or -2, right? So in this one, if you factor that, it should give you the 2 solution, 6 and 8. And the second one that can be considered as a perfect square, so x minus 4. Sorry. My bad. This is 4 and 8. And this is x minus 6 squared, so that gives you a solution of 6. So we have totally 4, totally we have 3 solutions, 4, 6, 8, sum them up. We should get C, right? Yeah. All right. All right, let's move to the next slide. Okay, this is a questions of number 7 in 10A. Also, this shows again in the number, this is a question number 5 in 12A. So in 10A and 12A, totally they have 11 questions in common. So this is a reason that you can now take the two tests together. So you can only choose one of them. Okay. So this is one question that in common. Also, this is not very difficult questions. Number 7 in 10A. So there's a 25 integers from -10 to 14 inclusive can be arranged to form a 5 by 5 square. So we consider as a magic squares, in which the sum of number in each row, the sum of the number in each column, and the sum of the number along each of the main diagonals are all the same. So what is the value of this common sum? Okay, so they give you a series of integers, totally is 25 of them. So let's say I list them out. So oops, sorry. Oops. Okay. All right, should be fine. So I list them out, -10, -9, -8, all the way to -1, 0, 1, all the way to 10, 11, to 14, right? So this is 25 integers. So if they fill into a 5 by 5 square, okay, let's count like horizontally. They told you that for each row, they have a sum, right? So we have a 5 value in one row and 5 value in another row. So each row, they should have a common sum. So the sum of these 5 rows should be the same. Okay. And think about how you get this common sum. So if we sum up all the numbers, all 25 integers, that should give you a total. And we know is each one of them, we totally have 5 this sum, right? And we sum them up and that give you the total sum. So that would be pretty easy to get this the common sum because each one of them should have the same value. So the question is, we just need to sum up this 25 integer and divide by 5, right? Okay, so that should give you this common sum. So based on the integer I list here, so you can find out the pattern. So up to the integer positive 11. So if you sum up the first 21 integers, that should give you a sum of 0, right? Because the negative 10, my bad. The first 21 integers. So negative 10, positive 10, negative 9, positive 9, right? So if you sum them up, that should give you 0. So if you sum up the rest of 4, 11, 12, 13, and 14. So that should give you the total sum, right? Plus a 0 in the front, divide by 5. So this should be the sum of each row, and also it should be the same value of each column, and it should be the same sum of the main diagonal. So this result should give you the answer 10, which is C. Okay, all right. Let's continue. Next question on the right of the screen is also pretty easy. So this is arithmetic. We consider as the arithmetics series, right? But a little different because you can find out if all of them is a addition, so that would be pretty easy. So you just add from 1 to 200, right? But some of them is not addition, is subtraction. Okay, so like here is a negative 4, negative 8, negative 12, all the way to negative 200. Okay, yeah, so I'm assuming that you can get this question correct, but just doing this quick. So this one can be rewrite into what? 1 plus 2 plus 3 plus all the way to 200. This is the way I did it. And if I doing this, if I get a series like that, I count like say 4 twice because it should subtract 4, but I add a 4, right? So I need to minus double of this 4. Let's say I plus 4 here on the top and minus double of 4, and the result can give you a negative 4, right? So similarly, if here in the I plus 8 on the first row, and here I need to minus double of 8, right? And if I rewrite the giving series into the series of that plus the second series, in this way, I can use the arithmetic series formula, right? So should be 1 plus 200 times 200 over 2, right? So that will be the value of the series in the first minus, okay, I can subtract 2 out. So that will be 4. So here it will be 4 plus 8 plus all the way to 200. So for this part, I can subtract another 4 out, right? And that gives you 1 plus 2 plus all the way to 50. So you can do the sum from 1 to 50 in the second. Okay. Yeah, so that will be 20 2100. So the answer for that should be 9900. Okay, answer should be B. Oh, I saw someone have questions. Let me check pretty quick. Okay, let's continue. All right. Next screen here, starting from the first question in the 12. Yeah, this is also a pretty easy question for the percentage, right? Yeah, so took 70% of whole pies and the other persons take 1/3 of remainder. So what portion of original one was left, right? So this one should be pretty, it's a piece of cake. So the answer is C. Okay. All right, next one. Okay, so this is also a question in commons from 10 and 12As. So this is number 4 in 10A and number 3 in 12A. So a driver travels for 2 hours at 60 miles per hour, during which for a car gets 30 miles per gallon of gasoline. She is paid 50 cents per mile, and her only expense is gasoline at $2 per gallon. So what's her net rate of pay in dollar per hour after this express? So don't confuse about the so many unit, and they have a 2 type of the rate. Okay, so you need to be clear on that. The first one is that she is paid $0.5 per mile. So since she is a driver, so you need to have some income. So this part, $0.5 per mile is the rate of income, right? I'll just call that that way. Okay, and the other numbers in dollar here is the express in gas. So this part is the express in gas. Obviously that the question asks you the net rate of pay. So we need to collect the total income minus the express, right? And that can give you the net of income, right? So this is the idea. And if you understand that the question is actually pretty simple. So we can count the total distance is traveled. So 2 hours. I suggest to handle this type of question, you can write down the number with the unit, right? So that can give you the hint what that number means. So we have 2 hours and 60 miles per hour, and that gives you 120 miles. So that would be the total distance. And based on that, we can get the income should be $0.5 per mile times 120 mile. So that should give you $60. So that is the total income. And then we need to find out the expense. So for expense, it said is $2 per gallon. So we need to also gallons. We also need to find out how many gallons is used for this trip, right? For that one, we can use the one on the top. It said the MPG it shows is 30 miles per gallon of gasoline. So based on that, we got total distance will be 120 miles over the MPG, 30 miles per gallon of gasoline. So based on that, we got the total expense in the gas is $8. Okay, and we subtract that, we got the total the net income will be the difference. And since they asked for the rate per hour, the total distance is 2 hours, right? So that give you $26 per hour, right? So answer is E. All right. Okay. Next question. So this is the question number 11 in 10A, and this is also the problem number 8 in 12A. It's also a problem in Commons. So what is the medians of the following list of 40 numbers? So the first 20 numbers would be 1, 2, 3 all the way to 2020. And the second half will be the perfect square, right? So 1 square, 2 square, 3 square, all the way to 20 square. So they want to find out the median. Okay, let's recap how you find out the median of series of numbers which have the even amount. So if we have an even amount in the series, so the median has to be the average of middle two, right? So we need to find which two is the middle two. So in this case, we have number 2020s. So actually, this two in the expression here. So number 2020s and the number 2021st, right? So the answer, we just need to find out which is the value of this two after we resort that, right? Yeah, we know that if you need to find out the median, so all the number has to be sorted. So this obviously is sorted. So let's list the first half: 1, 2, 3, 4. Let's try another one, and all the way to, let's say, 2019, 2020. Okay. So this is the first half. And when you consider to plug in the second half, so obviously we know that there's some number at the back of the second half is extremely large. It's obviously it should be shown on the back, right? But we know there's some number I need to plug into the first half. Let's say 1 square, right? 1 square has to be plugged into here, right? Because that is less than 2. Okay, how about 2 square? Yeah, 2 square also need to plug into the first half, right? Okay, and then the question is clear, like how many numbers or how many square of the perfect square I need to plug into the first half if I need to sort all numbers, right? So this is actually the question. So think about it, how many number I need to plug in? So this lead to, since all the second half are perfect square, okay? So there should have one perfect square less than 2020, and the next perfect square of that should be greater than 2020, right? So we need to study about which perfect square is belong to this case. So let's take a root of 2020, and we could find that approximately. So this root, it should greater than 44 and less than 45. And it will be clear that the square of 44, it should less than 2020. And the one greater than that, let's say 45 square, is obviously is just behind the 2020 if I sort it, right? So I need to plug in here 44 square in front of this 2020. Okay, and 45 square should be sort behind of that. Okay, hopefully that is clear enough. And since we already plugged 44 number or 44 perfect square in the first half, And automatically, so this number has to be pulled back, let's say 44 orders, right? So we just subtract this out of it. So 2020 minus 44 should give you the value of 1976. Okay, so at this location now, change into the value of 1976. And the next location now should be 1977. Okay. All right. After I got the value of the 2020's number and 2021's number, which is 1976 and 1977, I just find out the average of the middle two. Should give you the answer of C, right? All right, let's move on to the next slide. All right, so let's read this fraction. This is the problem number 14 in 10A. So we have a real number x and y satisfy this following: x plus y equal to 4 and x times y is -2. What is the value of this expression? Okay, I don't have very efficient way to solve that. I just need just follow the standard way. I combine the like term, and that should give you the I know the common denominator should be x squared y squared if I just combine them. So in that way, I got x cubed y squared plus x to power fifths y squared plus y fifths x squared plus x squared y cubed over the common denominators. Okay, and I can just combine the extracted like terms, and that should give you the x cubed plus y cubed times x squared plus y squared on the top, and on the bottom should be the same x squared y squared. All right, so the next fraction is we just need to rewrite the sum of the square and the sum of the cube in terms of the giving two expression x plus y and x minus y. Okay, so for the polynomial, there's some of the product identities everyone should know about. Like say we have x plus y squared equal to x squared plus y squared plus double xy, right? And obviously x squared minus y squared equal to x minus y times x plus y. And for the cube, we have x plus y cube should be x plus y times x squared. Oh, sorry for that. Can I read it? Yeah. So x squared, x cubed plus y cubed, because we want the sum of the cube, right? The sum of cube. So in this way is x plus y times x squared plus what's that? Sorry. Let me erase that. My initial writing is still correct. Because we have x plus y, right? So let's say x plus y cube should be x plus y time, x cube plus y cube plus 3 times of x squared y plus 3 times of xy cube. Right? So in that way, I can rewrite a x cubed plus y cubed in the way of x plus y cubed minus 3 times of x plus y. Right? Okay. Similarly, I can rewrite that x squared plus y squared by x plus y squared minus double xy. Right? So this is how I'm going to do later. So I can have x plus y cubed minus the 3 times xy, x plus y. And the second factors can be rewrite into x plus y squared minus double xy. Okay. And we keep the denominator unchanged. And then we plug in the value we have into that expressions. So the answer for this, if you plug in correctly, you should get 88 on the first big bracket and 20 in the second bracket. On the bottom is 4. So the answer should be 404. Okay, let's move on to the next question. So this is a question about the radical expressions. Okay, so we have integer a, b, and c. Each one of them is greater than 1. So they give you an expression like that, big radical expressions. And for all n greater than 1, they want to find out the value b. Okay, so we know that if we have an exponent like a radical expression, so n root of a and to the power of b, so that can be right into the form of b over a, right? Yeah, just using that very basic rules for the radical exponent. Okay, I can rewrite that the expression on the left by starting from inside. So this part is n to the power 1 as 1 over c. So time n, so I just plus 1 on the top, right? So we know that, yeah, so this is another property for the exponent. Everyone should know that. And to the root of b, okay? So I multiply 1 over b in that case. And then I plus another 1 because they have another n outside. Multiply to the radicals. Okay, and we have a big root of a outside. So we add another bracket and multiply 1 over a. Okay, so this should equal to n to the power 25 over 36. Okay, and then since the equations work, so the exponent of n should match on both sides. So I can rewrite that into, just simplify the expression, the exponent on the left. So I can get 1 plus c plus bc over abc. So A times B times C will be the new denominators. So that value should equal to 25 over 36. Okay. And then I don't have much information about ABC. We only know that all of the ABC are integers, right? So we need to work on that. So I have ABC, A times B times C should equal to 36. And 1 plus C plus BC should be 25. In the other hand, I got C plus BC should be 24. So I can also write in C times 1 plus B. So this one, all right, write C on the back. So that should be 24. Right? I get a system like that. Okay, so obviously C is the common factor. So, but we don't know what's value it. But we know 36, 24, they have some common factors, right? So we can choose the different common factors to make that all A, B, C are integer. This is what we need to do. So let's say starting from the very beginning, the smallest one, which is 2. So if C equal to 2, okay, so based on the second, so B must be 11. Well, but 11 is not a factor of 36, so this doesn't work. Okay, let's try next one. So will be 3. 3 will be a factor of, or the common factor of 36 and 24. So if C equal to 3, so leave B equal to what? 7, right? 7. Also, this doesn't work because the value of B must be a factor of 36 in the first equation. All right, I try another one. Let's say 4. If C equal to 4, so B equal to 5. Also doesn't work. I try one more. C equal to 6. So if C equal to 6, so we give the B value as 3. Okay, so that should work because 3 now is a factor of 36, right? Okay, and also that leaves you A is 2. Okay, all of that A, B, C are integer and greater than 1. So that should give, this should be work for a combination. So based on that, B should be 3. All right, let's move on to the next one. All right, so this is the collection about a polynomial P of X. Okay, so this is actually 100 degrees of polynomials, right? So we actually know where the root is. They have 100 roots, right? So each root is a perfect square. 1 square, 2 square, 3 square, all the way to 100 square, right? So we have 100 roots. So this is the 100 degrees polynomial. So they want to know how many integers of n are there such that the P of n is less than or equal to 0. Okay, so this is the polynomial inequalities. Okay, very standards. Let's list them out. Mark all the roots on the number lines. So starting from 1 square, 2 square, 3 square. Yes, it's not in a good scale, but it should work well. So 97 squared, 98 squared, 99 squared. Okay, 100 squared, right? All right, so based on the knowledge to solve a polynomial inequality, we know that we can draw the line, go through all the roots, right? Like that. All right, continue on working this. And all the values underneath that represent the value less than or equal to 0, right? Less than equal to, which means that the roots should be inclusive, right? Okay. This is the first this is the first range of your solution, and this will be the second range of solution of shaded area, shaded part, right? Yeah, we have a totally 50 of that range. Okay, and the next question is need to find out how many integers in each different range. Okay, so how many integer between the square root of 99 to 100 square root of 100? Okay, so it should be 100 square minus 99 square. Is that true? Well, think about that. This will be like a very common mistake. Let's say we have 1, 2, 3, 4, 5. Okay, how many numbers totally in this series? Pretty easy, right? So we have 5 numbers. But if you need to use the last number minus the first one, that gives you 4 instead of 5, right? So this is how we get the total amount if they are like a consecutive integers in the series. So use the last one minus the first one. Don't forget, because it's inclusive, both and is inclusive. So we need to add a 1 as last. So we have totally 5 numbers. Similarly, to answer this question, so we use the last integers on the edge minus the first edge plus 1. So this is total amount of integers in this range, right? Okay, we can continue work for the rest of it. So this one, it should be 98 square minus 97 square plus 1. Okay, and dot, 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 dot. The last one, it should be 2 square minus 1 square plus 1. So what we need to do, we just sum them up. Okay, even it's not look very neat, but after I rearrange it, it'll be look a little bit better. So I have 100 square minus 99 square plus 98 square minus 97 square plus dot, 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 all the way to 2 square minus 1 square plus, how many ones here? Because each group have a 1 to add, right? So obviously that I group 2, totally we have 100 numbers, so we have 50 groups. So 1 times 50. All right, and how to solve that? If you take a look at that, we mentioned about x squared minus y squared equal to x minus y times x plus y, right? So using that formula, I can rewrite into 100 minus 99 times 100 plus 99. So the first group can be rewrite into 100 plus 99 directly, because we know the difference between the 199 is just 1. Okay, so that makes it more similar. So the more easier. Like the second one, I can using the same technique to rewrite that into what 1 time 98 minus 97, right? Okay, so the first B group, I can rewrite into 100 plus 99 plus 98. This is plus, right? So this will be the difference in the first. Plus 97 plus all the way to 1. So we just need to find out the regular series from 1 to 100. Don't forget to plus another 50. So we know the first part is 50-50 plus another 50. So the answer should be 5100. Oh, someone's mentioned that there's nausea when I write. Okay. Yeah, just adjust my mic. All right, let's take a look at that question here. So this is question number 21 in 10A. Also, this is the question number 19 in 12A. Okay. So it mentioned like this: there exists a unit strict increasing sequence of non-negative integers, a1, a2, all the way to ak, such that there's a very large exponent. So 2 to the power 289 plus 1 over 2 to the power 17 plus 1 equal to the sum of the exponents based on 2. And they want to find out what is k. To understand a fraction, what is the k? What does k mean? So k is not the value of the index of exponent, like showing in the last here. Yeah, so k is not the exponent of 2, the last exponent, but k is the number of exponents, right? Because k is the index of that a, right? So they want to know like how many of this exponent based on 2. Okay, so this is the first things we need to understand about that. What is k? What do they want? They want to know how many instead of which. Well, what is the value of the last exponent? Okay, then if you take a look of the first big one, so we have 2 to the power 289. What's the relation of 289 and 17? So you already as a starters of each fraction, so we should like observe any relation among the numbers. Okay, so obviously you can figure out 289 is actually the square of 17, right? So I can rewrite the expression here: 2 to the power 289 plus 1 over 217 plus 1 into 2 to the power 17. Okay, be careful. I cannot just square that, because if in doing so, they give you 2 to the power 34. So what I need to do is to the power 17 again. Okay, plus 1 over 2 to the power 17 plus 1. Okay, since this 2 to the power 17 it shows twice, okay, I prefer to substitute by another variable, let's say x. So I set 2 to the power 17 into an x. So in this way, I can make the expression on the left is a little bit neat. So that can be right into x to the power 17 plus 1 over x plus 1. Okay, what's that equals? So we have the formula for this type. So if we have x squared plus 1 squared, so we know we can rewrite that into x plus 1 times x squared minus x plus 1. So it should be like showing plus or minus alternatively, and all in the middle term will be canceled out. Only the first and the last term will be the cube will be left, right? So this is for the third. And the fifth, it should give you the same, right? X to the power fifth plus 1 to the power fifth. So it should follow the same patterns. So we can extract a common factor x plus 1 out in this way. And the second term will be x to the power 4 minus x to the power 3 plus x squared minus x plus 1. So in order to cancel out all the internal terms, so the second big term, it should be alternative, plus or minus. Okay, so follow the same pattern. We know that this part, x to the power 17 plus 1 over x plus 1, can be now rewrite into x to the power 16 minus x to the power 15 plus x to the power 14, blah, blah, blah. Yeah, so x minus 1, right? Yeah, sorry, minus x plus 1, right? Yeah, you can see the patterns in the first two. All right, so this one, if I continue to simplify it, I can regroup that. Like this. So this part I can get x to the power 15 times x minus 1. And this is supposed to be x to the power 14 minus x to the power 13, right? So I can do the same, x to the power 13 times x minus 1, all the way to just x minus 1, right? So in this way, I can rewrite this form into x to the power 15 plus x to the power 13 plus all the way to the x. Hold on. You might find out a little problem because if I'm doing this, you should have an x in the front, but we have a plus 1, right? So where's that 1? Because x times x minus 1 is just stop here, which means I forgot to plus 1 on the left. So don't forget of that. Okay. You can see that in this line, the last term is plus 1 without including plus 1. So I only stop at minus x. So I need to plus the 1 at the end. Okay. All right. And then since we know the k represents the number of the exponent based on 2, so now I have an x. So x is exponent 2 to the power 17, right? Okay, so this gives you the what? This x minus 1 basically is just 2 to the power 17 minus 1. Okay, so using the same technique, but a little bit different, but like x to power 17 minus 1 to the power 17. Similarly, I should get x plus 1 times x 16 plus x to power 15 plus blah, 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 all the way to 1, right? Sorry, this should be a negative instead. Okay, so to substitute x by 2, so these factors can be rewrite into 2 to the power 16 plus 2 to the power 15 plus all the way to the 2 to the power 0, this is 1, right? Yeah. And all the item in the first factors, let's say this one, like if I plug in, that should give you like a 2 to the power 255, okay, plus 2 to the power 221, right? So how many factor in the front time this part we should have 17 item in the second parenthesis, right? So that's lead to you how many exponent we can have. Like the first part, like x to the power 15 plus x to the power 13 to the all the way to the x to the power 1. So we should have 8 items in the first parenthesis, right? And we have 17 items in the second parenthesis. So that leads to you 8 times 17 items after you do the multiplication. But don't forget, we still have a 1. 1 will be considered as 2 to the power 0. So we have another item left. So that should give you the total amount of exponent based on 2 on the right. Yeah, so this should give you the answer of 137. All right, let's try another question here. So that will be the last question in the 12A. Surprisingly, it's algebra questions this year. All right, so this is a the question is say like this. So the number of A is it can be write into I say a ratio of two integers, P over Q, and P and Q are relative prime positive integers. So that also give you the information that A is a positive, right? So have the property that the sum of all real number X satisfied is 420. So this is an equation. Basically, it's just an equation, right? So the sum of all real solution, like the number of X satisfied is the equation is called the solution of that equation, right? Okay, so the sum of all the real solutions of this equation is 420, right? Okay, so here we have two expression. So the first one that you know that the greater integer less than or equal to X, which is just round down. If we give you a real number, and that would be round down to the nearest integers. Let's say 2.2. Okay, so after I took by this expression, that should give you 2. Yeah. So in math, this is also called a floor function. Yeah, I take the floor of that giving real numbers. Okay, and the brace of X equal to the X minus the floor of X. So that is the fractional part of X. Let's say 2.2. So after I take the brace, the result it should be 0.2, right? Pretty clear. All right. Yeah. So this is the help you to understanding the question itself. So they want to know after I figure out the value of A. So they want to find out the sum of the numerator and denominators P and Q. All right. Let's analyze what kind of this equation is. On the right of this equation, A times X squared. Basically, it's just a parabola, right? So on the left, what is that is? Yeah, if you stuck on that, if you especially for those questions in the last few very challenging questions in AMC, so you might consider the question using some examples. Okay. Let's say if X is the value between, let's say, 0 to 1, what's happened? What is the output of that, the expression on the left? Okay, for instance, if X, let's say 0.2, okay? So in that case, I take the floor of 0.2 and then multiply the fractional part. Obviously, since the 0.2, I take the floor or round down to 0, right? So 0 times anything, so that should give you 0, right? Okay, so that's give you the result of 0. Actually, all the value between 0 and the 1, before 1, the value should be 0, correct? Yeah, because the floor function give you the result of 0. And then we try the other example. What about if I take X between 1 and 2, 1 and 2, let's say 1.2. So in that case, I got the floor function is 1, and the second part is 0.2. So the result is 0.2. So they have a value now, okay? And let's consider another value between 1 and 2. Let's say X equal to 1.6. So since the floor function still be 1, right? So the output of the left part, it should be 0.6, right? So if X equal to 1.6, and this part should be 0.6, okay? It we consider as a kind of linear result, right? Okay. Try another one. What about if this is another integer? Let's say 2. So if it's an integers, so the floor functions is itself, but the fractional part is 0. So we can get pretty clear that if your x is an integer, the output has to be 0. Okay. All right. If you continue working on that, you can find out. Okay, so the whole function on the left part, if you consider as a function, is a part of line segment, right? If I draw that on the coordinate system, it's like that. So between 0 and 1, 2, 3, 4. Okay. So initially from 0 to 1, that gives you 0. And 1 to 2, okay? So it will be increased linearly to the what? Before they reach to 1. But when they reach to 2, it just drops back to 0. Okay? We know that all the integers, the output should be 0. That gives you a segment between 1 and 2. And in the between 2 and 3, okay, so they can also reach, let's say, x equal to 2.9. So the result should be 2 times 0.9, right? So you just like the slope will be different as the first segment. So like that. It should be linear. Okay. And we can consider for the next segment, so the slope will be increased as well, like this. Yeah. All right. So we can continue working on that. And this is the expressions of the left part of this equation. But what about if x is a negative? So far, I only consider x is a positive, right? So if x is a negative, like take example, x equal to negative 0.2. So in that way, I can get the first part. It should be the integer less than that. So -1 times the fractional part. So using the value minus that. So should be what? -0.2 minus or plus 1, right? So you can find out the output is a negative value. So here is 0.8, and should be times -0.8, right? So anyhow, I can find out that it should show somewhere here. So the output has to be a negative. However, we know that on the right, a times x squared, a is a positive. So we want to find out intersection of this expression on the left and the parabolas. So the parabolas is all positive, right? So obviously on the left side, if x less than 0, there's no intersection. Okay, we don't need to worry about that anymore. Okay. Okay. All right, then we try to find out, rewrite this expression by some, since they are linear segment, we want to find out the expression for each one of them. If you summarize that, this part will be y equal to, since the slope is 1 times x minus 1, right? So that will be the expression of first segment. And this part, it should be y equal to, the slope is 2 now, times x minus 2, okay? Continue working on that, we can get y equal to m times x minus m, right? But it's only work in the specific segment domain for different p's, right? So x in that way should greater than, let's say, equal to m, and m plus 1. right? So that should give you expressions for this. Okay, so hopefully that make a little sense to you. And I rewrite a very weird expressions or function into a linear function now. So now the next step, we just need to set this one into the equation. Okay. Yeah, there's still a lot of algebra steps after that, but let me make it straight. If you give this is the quadratic equations. So the result is x equal to m times a big irrational expression, 1 plus or minus root of 1 minus 4a over 2a, right? This part. Okay, since we know that if you analyze with the difference between the two solutions, you can find that plus or minus the difference between this is greater than 1. So only one intersection is alone in each segment. Okay, so in that way we chose the minus 1, because the 1 plus the bigger one is out of scope, right? So we just chose the smaller one. So that it should give you the each intersections on the graph. Okay, so this m can be some value. Let's say in the first segment m equal to 1, second segment m equal to 2, and then continue working that. So we know that this actually gives you the solution, right? Okay, so we need to sum up all the solutions, and that give you 420. Okay, so we need to sum up the solutions. So m can be 1, can be 2. Well, we don't know like where is stop. We need to figure out what is the last solution shown in these expressions. Let's say we have ends of solutions. In that way, m can be chosen from 1, 2, all the way to n, right? Yeah, and then we sum them up. So it will be x1 plus x2 plus xn, right? So, and we can find out in the in the parentheses here, it's just a constant in terms of a, right? So in that way, when you do this summation, that gives you 1 plus 2 plus all the way to n times this big parenthesis. Let's say call this like a x, right? Like a big x here, and that should equal to 420. And we know this part, run out of space here. I will erase the example on the left. Okay, I can write this part is n times n plus 1 over 2 times this big x equal to 420. And we know that, so to figure out the n, let's say, is there any other restriction we can get? So think about 1 is raised to the right, the last possible intersection between 28, x equal to 28 to 29, so in that range. So that will be the last one. Okay, so after it, there'll be some values like n and n plus 1, right? Yeah, so I already told it should be 20, so n value should be 20, 28, but I figured out why. Yeah, so that will be the last one. Your m chose as n. You got the last solution shows, right? So which means that the one after it, there's no intersection anymore, right? So this is the restrictions that your last m should satisfy, or your n should satisfy. Okay, so so in that case, I can get this one if I rewrite that in this form over 2 this big X. Yeah, should be 1 minus, just read it out, A over 2A is equal to second times. But you can also tell that the n value times the big X here, whatever it is, that should be your solutions, right? So n will be the value chosen from 1 all the way to n. But if the last value I chose for m is this n, so this part times the x is already your last solutions. So that is what we need to satisfy for this result. So this last solutions should in the last range, which is between n and n plus 1, right? This is what I said. Okay, after that, after this n, let's say n plus 1. So in the range of n plus 1 and n plus 2, there's no solution anymore. Yes. So based on that, I can get another inequality, like a restrictions that n should satisfy. And based on this, if you well, we kind of run out of time. Just look faster on that. If you solve this, this is give you the value I mentioned. It should be 28. Okay, after that, I plug back into it. I got I got 28 times this big X. So now I need to find out the exact expressions. 1 minus 4A over this 2A. And this should equal to, let's check out here, that give you 840 over n plus 1 should be 29. Okay, so after you figure out the last solutions, we have it should be occurred between 28 and 29, right? So totally we have 28 of solutions, and then we plug back inside. I got an expression for A only, and with some algebra, I just rearrange it. It should give you the result of A, which is 29 out of 900. Yeah, and the question is asked you to find out the sum of the denominator and numerator of A, which is 929. Yeah. So this question's it's not easy, of course. That is the last question of number 12A, and hopefully that gives you some hint how you're starting with this type of challenge questions. So if you like, we can try with some examples, right? Plug in some values, and then you can get a hint of that function look like, and then we can work on that after it. All right, I think that's done for algebra. I should go quick because it's almost 1 hour and a half past. Okay. Let's move on to the geometry. Okay, the first two questions here will be pretty basic. Like first one, AMC, right? So we need to find out the sum of the lengths, and just find out using the distance formula to find out the length. First one, the answer will be C. Okay, the second one. So in the page figure shown below, 3 of unit has been shaded. So what is the least number of additional units squared that must be shaded so that the result features have 2 lines of symmetry? Okay, so after you fill all the you shaded the additional squares and make the symmetry, right? Make this symmetric. So they should have a 2 line of symmetry. Okay, first of all, it has to be a horizontal line in the middle, like that, right? yeah, so this just you fold upper part down, so that is it should symmetric. And second one can be the line in the middle, right? So based on that, I can get this one has to be shaded, right? Because we already have a shade below this line, and this part has to be shaded, and this part has to be shaded, right? So for the right, the line of symmetry, I got this 3 additional square has to be shaded, okay? And since this one for the vertical line of symmetry, so this part has been shaded on the right corner. So the left right corner has to be shaded as well, right? And this part, so this one has to be shaded. Similarly, this one has to be shaded, and this one has to be shaded, right? So we sum them up. So they should have 7 additional square need to be shaded. Okay. All right. Next question. It's also a question in common of 10A and 12A. So we have 7 cubes, and each one of them have a bottom of 1, 8, 27. Okay, so you can find out that we have a 1, 2, 3, 4, 5, 6, 7. We have 7 cubes, and the length of edge should be 1, 2, 3, 4, all the way to 7, right? Yeah. And it's stacked vertically. Okay, so except from the bottom cube, the bottom face of each cube lies completely on top of the cube below it. What is the total surface area of the tower? Okay, so basically we just need to find out the total surface area of each cube, right? And we sum them up, and we need to subtract the area has been like overlapped by adjacent cubes, right? For instance, if I have a cube here on the bottom, and I have a smaller cube, yes. That's not good. So this part, the shaded part, it should be subtract from the total surface area. But additionally, it has to be subtract twice, because like if they are overlapped, and this surface area, it should subtract twice. One from the cube from the top, which is the bottom surface, and also the surface from the bottom will be the top surface of the bottom cube, right? All right. So based on this understanding, if you write out the expressions, so for the one on the bottom, since they have an edge of 7, there's 6, so we find out the surface area, and totally have 6 of them. So that will be the total surface area of the very bottom cube. Okay, just add all of them up. So 6 squared times 6 plus all the way to 1 squared times 6. Okay, so that is the total surface area if they are not stacked, and minus the area has been overlapped. 7 squared plus 6 squared plus all to 1 squared, right? Yeah, and this should give you the result of 658, which is B. Right. All right, next one on the right. This is question number 12 on the problem on the 10A. So we have a triangle AMC, right? And it's an isosceles triangle, and AM equal to AC. Median MB and CU. So these two segments considered as a median. So that give you the information that U is the midpoint of AM, B is the midpoint of AC. Okay, and these two medians are perpendicular to each other, and each one of them have a length of 12. So what is the area of the triangle AMC? Okay, so for this question or type of question, so obviously that since we know that very clear of information of the midpoint, so if I connect those, so the triangle, the top triangle AUV is should similar to the triangle AMC, right? So triangle AUV should similar to the triangle AMC. All right. On the bottom is the trapezoid. And we also know the diagonal of this trapezoid is isogonal or perpendicular to each other. If you know that rules, though, the area of this the trapezoid UVCM should be the half of the product of the two diagonal. So it'll be 12 times 12. Yeah, and then it should be a piece of cake. But if you don't know that, it's fine. Let's say we don't know that, but we just need to find out, since we know that the top triangle is similar to the big one, and the ratio is half, right? Because of V and of U will be the midpoint. So the area of the UVCM, it should be what? It should be just 3/4, right? Because the top one is just one quarter of the area of the big one, the top, the triangle AMC, right? So which left the trapezoid have an area of 3/4. Okay, so to figure out that, we can separate it in this way. And this. Okay, we can separate the trapezoid into two triangles. And the base is 12. We just need to find out the height, right? The height. Here we don't know. So there's also a very standard strategies that if you don't know the length of some segment, you can just define it in a variable and then convert the geometric fraction into equation. Okay, you try to establish equations based on your variables you define. Okay, just like here, I have an h here. So in the other, like if the top part, the top height is h, and this second part should be 12 minus h, right? So the area of this trapezoid has to be half 12 times h plus 12 times 12 minus h. Okay, yeah, you can find out. Okay, so even we don't know what the value of h is, but is cancel out, right? So that leaves you the answer that the area of the trapezoid is just half of 12 times 12. This is in this formula. Okay, after you got that, the big triangle AMC, area of that, the area of the trapezoid just 3/4 of the area of AMC. Okay, so that can give you the answer of C 96, I believe. All right, here is another question for the quadrilateral. It's number 20 and 10A and number 18 on 12A. Okay, So in this question, it told you we have a quadrilateral ABCD and satisfy the following. So the angle, the measure of angle ABC is 90. So we have a right angle starting from that. ABC. Okay, and ACD, AC, I just connect that. And the D is somewhere here, right? D is here. Okay, and that is another right angle. And AC is 20, and CD is 30. All right, and I connect A and D, that's form a quadrilateral now. Okay, and diagonal AC and the BD intersects at point E. Okay, I just connect those. That give you the point E here in the middle. Okay, and it told you AE is 5, and automatically that C is 15, right? So what is area of the trapezoid? Very easily we can get the area of ACD, since the C is the right angle, right? ACD is the right angle. So the area of this triangle should be pretty easy to figure out. 20 times 30, so it should be 300. So we just need to find out the area of this right triangle ABC. Right? If you got that, we sum them up. It should be the area of the quadrilateral. Okay. Similarly, as I discussed in the last questions, so if you want to figure out, like say, for this triangle, I lack of information about the AB, the length of AB and BC, but we know the length of hypotenuse, which is 20. So if for any case I can find out the height, I will figure out the area of this triangle ABC, right? Let's say we have the height here, h. Just as I said, if you don't know, you can define it with some variable. Let's say I define it as h. So since this is h, so this part, it should be is the right angle here. Okay, and then I can find out by using another colors. So this triangle, the right triangle, and this right triangle should be similar, right? Should be similar. And based on that, we know EC is 15 and DC is 30. So this is like double the length. So it should same the ratio. It should have the same ratio as this triangle, the smaller triangle. So if I define one leg as h, so this part has to be half of h, right? Great. And based on that, so this little part, it should be 5 minus half of h. All right. Then let's take a look at this triangle. The triangle in blue, in green. Okay. Yeah, we know this height, and we know the two lengths adjacent to it, and we know that if we have a triangle, let's say this is A, B, and C, right? So A over C should equal to C over B because they are similar. And the automatic gut relation is that the height C, I square it, it should be the product of the two, which is the two legs here. Okay, and that give you the, okay, that can give you the equation. Let's go back to the red. So h squared should equal to 5 minus half h times half h. Be careful that here is half an h, and here is another 15 plus 15. All right, and you just solve this quadratic equation that h that give you a 6. Okay, when you plug back inside, I can get the area of ABC should be half 6 and 20. That give you 60. Sum them up, answer should be 360. All right. Next question here in the geometries. Okay, so we have a regular octagon, A, B, C, D, E, F, G, H, right? So you have a 8 vertexes, right? So regular octagons. Have area of n. So let m be the area of the quadrilateral ACEG. Yeah, so first we need to draw this regular octagons. Okay, I marked each vertex by A, B, C, D, G, H. Okay, and by link A and C, C and E, A and G, and G and E. Okay, so that's quadrilateral. Well, you can prove that is this a square. Okay, so I just need to find out the ratio, right? The ratio of the square and the regular octagon, right? So you can define that the edge of octagon is 1. So based on that, I can get, well, in this way, since it's a 12A question, I can use the trigonometries. So in here, all right, so I can figure out that like the area of that triangles. Like we know the formula is law of the sine. So if we have a triangle, let's say we know this 2 leg and the angle in between C, is angle C, this is capital C, right? So area of this triangle can be right into half times the product of the 2 leg times the sine of the angle in between, right? This law of the sine. And also for the law of the cosine, we can also get the C squared equal to A squared plus B squared minus double A times B times cosine of this angle C, right? Yeah, so that is the, we need to know about the law of the sine and law of the cosine. So we can just use that directly. So based on that, first of all, we can find out the length of AC, right? So that one use the law of the cosine, AC squared. So it should be A squared 1 squared plus 1 squared minus double 1 times 1 times cosine. Okay, so this angle, based on the property of the regular octagons, so that should be 135, right? So 135. And we can get this value, AC should be 2 plus root of 2, right? And also, this 2 plus root of 2 should be the area of this square. Okay. All right. And this is also the value of M. Okay. And then we need to figure out the area of the regular octagons. So that is just the area of the square plus 4 of congruent triangle, right? So we're using the law of the sine to get the area of each. So the area of each triangle should be half 1 times sine of 135. So that should give you over 3. I'm sorry, root of 2. Right? Okay. And the m in that case should be what? So be the m will be the area of the square plus 4 of the area of each triangle. Okay, and yeah, we just need to find out the ratio of that. And m over n, in that case, should be half of root of 2. Also. All right, there's some question here. There's a question poll from Jing. So question number 10 should now subtract 2 to the power of 7. I'm not sure which question 10 you mentioned. Let's go back a little bit. Is that this questions? Yeah, maybe I have some typos, I'm not sure. Yeah, but this one, they just find out the, we find out the total area of each cube. And since we have 7 of the cubes, right, we sum them up. And since they are stacked up and they are overlap, so it will be count twice for each surface, right? So is that the very big one? So we just minus the one surface for the upper cubes. And since it will be overlapped, so we need to subtract twice, right? Yeah. Okay, we done with that questions. All right, this one is the coordinate geometries. Okay, we have a line of the expression is a linear equations. So if this line has been rotated 45-degree counterclockwise about 1 point, obviously this point has, yeah, we can check. So if you plug it back inside 2020, so this is a point on the line, okay? So if we rotate with the point on this line by 45-degree counterclockwise and give another line. So they want to find out the new line, what is the x-intercept of this new line? Okay, so let's start that by drawing the first line. So 3x minus 5y plus 40 equal to 0. So we can get the y-intercept should be 8, right? And the point is 20. Is 20. So that's the little height. So that it should be the line L, and has been rotated 45 degrees. The new line. So this is the line K. This angle is 45. Yeah. And they want to find out the x-intercept of that. Well, okay. So for the line L, we can know the slope of the L should be 3 over 5, right? Yeah. So 3x plus 40 equal to 5y. Yeah. So we can get the slope of the first line before the rotations. Okay. Based on the knowledge of the line, so if the slope equal to this value, and we can get the angle here, the tangent of that angle should be the slope. Right? So you can check if you have a point on the line, and that will be considered as y over x, which is just the tangent theta, right? Y over x will be considered as the slope of this line, right? Yeah. Okay, so this angle, tangent of this angle should be 3 over 5. And also we can consider this is angle theta should be 3 over 5. Okay, and this big angle, let's say alpha. So alpha should be the sum of angle theta plus 45, right? This is the angle between the line L and M, and K, right? So if we get the tangent of that, tangent of alpha, so it should be the slope of the new line, right? Just the same definition. So using the formula for the tangent, that gives you the tangent theta plus tangent 45 is 1 over 1 minus tangent theta times 1 again. So it should give you 3 over 5 plus 1 over 1 minus 3/5. So it should give you 4. Okay, so tangent of alpha should be 4, which give you the slope of that line should be 4. Okay, and we know that this height is 20, right? So that can give you that this length should be what? Tangent is opposite over adjacent. Opposite is over adjacent. So in that way, this line should be 5. Okay, obviously that this point should be 15 on 30. All right, this is another questions. I think will be the last questions, I think, in the geometry. Oh, there's one more. Okay, let's just, we run out of time, let's just do one more. So that is for transportations. So, wow, this is also very long question. So if you have a very long questions, don't freak out, right? Use maybe a minute to read through. Maybe like this one is actually not that difficult. Let's read through that. Like T be the triangles in the coordinate plane with the vertexes 0, 0 origin, 4, 0, and 0, 3. You can pretty easy to get the, oops, sorry. Yeah, you can draw that triangle on the coordinate pretty easily because we have a point 0, 0, and this 4, 0 is locating here. 4, 0, and this 3, 0 is locating here. Okay, so that is the triangle. Mention the fractions. Okay, consider the following 5 type of transformations. So the first type, rotate 90 degrees counterclockwise. The second, rotate 180 degree counterclockwise. The third one is rotate 270 degree counterclockwise across the regions. Right, like the first one, if you rotate, okay, that give you, try another one. Yes. Right, this is the first transformations. If I need to do that, right, 180, just continue rotate this way, right? So yeah, that should make a lot of sense now. And the next transformation I mentioned is sort of refraction across the x-axis. For instance, I can flick down about the x-axis. It's a vertical reflection, so we give you this readout, right? Or reflect across the y-axis, right? So that gives you like this. If you rotate, right? It's just a flick over to the left, right? Okay, so we understand that we can do this 5 type transformations. And how many of 125 sequence of 3 of the transformation? What that mean? Okay, since we have 5 transformations, right, and they want to do it continually 3 times, so 5, 5, 5. How you get is 125, right? So the first transformation, you have 5 options. The second transformation, you have 5 options. The third transformation is you have 5 options. So 5, 5, 5. That's the so-called 125 sequence of the transformations. Well, is that not necessarily distinguished? So you can do 90-degree rotation once, and repeat it once, and repeat this 3rd time, right? You can do that. And after this type of transformation, some of them will return back to the original position. So they want to find out of that 125 way or operations, how many of those 125 can make the final location of the triangle go back to the original position? Well, yeah, the rest of it just give you an example. Think about that. This question is actually not very hard. You can find out the options is pretty less numbers, not the small numbers. Okay, let's try some example if you still stuck. Just like the example shown here, okay? Well, I can do flip, okay? If I flip to the left, let's say initial is on the red one. If I flip to the left, okay, because totally I have 3 chances, right? So I use once as a flip to the left, and then I can flip down. Okay, I got this one. Right, I got this one, and then I just have 1 chance to do the transformation. Okay, to go back to the red one. How can I do that? Okay, obviously I should do what? I should rotate 180 degree, right? So yeah, we can figure out once. So I can say I can do like vertical flip about the y-axis. So y-axis, okay, and horizontal flip, reflection about the s-axis, and then the rotation like a 180 degree, right? So I just find out example. Yeah, and well, the order actually doesn't matter, right? I can just flip over with the s-axis first. I got this one, and then I can flip with the y and go back to this the blue triangle, and then I rotate 180 degree, right? So since we have 3 different transformation, the order doesn't matter. So totally I can have 6, right? 6 different combinations. 3 times 2 times 1, right? I have 6 different combinations with the example shows. Okay. Okay. Is there other option? Well, this is only 6. Well, there's no option to have value of 6. What if we don't using the reflection, or we just have 1 reflection? Can we just have 1 reflection, 1 type, either across the x-axis or y-axis? Actually, is no. Why? Think about it. If you have just flip once to the left, you got this. Using another color like a pink one, right? No matter how you rotate, you cannot get the same shape anymore, right? If you just roll like the pink one, if you roll back, that's give you what? What that look like? That give you a triangle like this. Right? You cannot go back to the initial shape. Right? So only one reflection doesn't work well. You can try another one if I just flip to the bottom. And also with no matter what type of rotation, you cannot get the same shape. Okay, so which means that only one reflection doesn't work. But how about if I don't use reflections, I only rotate that. So you know that if I rotate, well, 360 degree, it's definitely go back to initial location, right? So the next possibility is the combination of 90 or 180 or 270. If I can make that integer multiple of 360, and that can give you other options. Okay, so very basic. I can get one possible solution is 90 plus 90 plus 180 because we only have 3 chances, right? So that can sum up as exactly 360 degree, and this is the integer multiple of 360, and that is rotate back to the initial location. So how many options in this case? Well, 180 can be shown in the first or second or third. We have 3 different ways, right? Well, another case is if I'm using like 180, yeah, on the 370 and 270 and 270. Is that? Let me check. Yeah. So I sum up that and give you 720, right? 720 is double 360, so it's just rotate 2 times. Or 2 revolutions, right? So also integer multiple of 360. So this is also works. How many ways? So 180 can be shown in the first or second or third, right? So also we have 3 other options or 3 other transformations. Well, you can see that this fraction, even this is number 23 in the 10A and the number 20 on the 12A, well, it's still doable, right? So, but you need to use, if you still have a little time when you reach out to these fractions, give it a little minute, like a 1 minute, to understand the fractions. If that's exact, like all the options, if it's the counting problem, all the options don't have too many, like the value is not large, well, still it's doable. Okay. Okay, let's proceed to the number theorem. All right. Yeah, as time, well, we run out of time, but I want to extend a little bit on that. I say there's some very good fractions. The knowledge will be used for you to prepare the next test. Okay, like this one. Okay, this is the fraction number 15 in 10A. So we have a positive integer, the positive integer divisor of 12 factorial is chosen at random. The probability that the divisor chosen is a perfect square can be expressed as m over n. So where m and n are relative prime positive integers. What is m and n here? Okay, let's starting from a topics of the prime factorizations. So how many integers, or say how many divisors of this 12 factorials? Okay. Remember, I go back to Okay, number of factors of dividers of 12 factorial. If you taking some training for AMC, the answer is like we go through the prime numbers and let's say like starting from 2. So this one can be right into 12 factorial equal to 2 to the power of some integers. Let's say E1 times 3 to power E2 times, it cannot be 5, it can be yeah, for this case, 2, 3, okay, also it could be 5 because they have a 5 in the expressions, E3, and they also have 7, right? So E2, E4, and also it's including 11, EF, right? So I can write in that way because 12 factorial is 12 times 11 times 10. All the way to 1, right? Like that. Okay, so we need to find out the E1, E2, E3, E4, and E5 in this case, right? All right. The way we're doing that is in this following, we can divide 12 by 2. We check about how many 2 inside of that, and we round down to the nearest nearest integers. So we have 6 of them. Okay, and also we count how many of 2 squared in that. So we have 3 of them, and then we continue working on that 2 to the power 3, and that give you 8. 12 over 8, that give you 1, right? So we sum them up, they give you 10 of them. But if you familiar with that, it'll be great. If you not, think about why we're doing so. So first, we count how many even numbers in this series. So we have 6 of them. Each one of them have a factor of 2, right? But some of them might be have a factor of the square of 2, like 4. Because 4 is in that. So if you divide 2, there still have a factor of 2 left, right? So we just count how many of this type. We have a 3 case, let's say 4, 8, right? 4, 8, 12 itself, right? So it'll be a factor of 4. So each one of them have an additional 2 as a factor. So we have another 3. And then we count, okay, how many of them? We have a cube of 2, like 8, right? Because after you divide 4, let's say 8, we still have a factor of 2 left. So that would be the last one. So I just sum them up. I got 6 plus 3 plus 1. So that would be like how many 2's in the factorizations. So you got 2 to the power 10. You can repeat this process like 3. You can do 12 over 3. How many of them? We got 4. And 12 over the square of 3. So we only have 1 left. So in that case, we have only 5 for the 5 of 3 in the factorization, right? So continue working on that. We got the prime factorization for this factorial. Okay, this is how you work with the figure out the number of divisor of any factorials. Okay. Well, that's actually the first step. You need to doing the factorizations, and then the number of that is what? Let's say since we have a 10 of 2, right? So you can pick up like 0, 2 or 1, 2 all the way to we chose all of that 10 2's, right? So we actually have we have 11th option to choose to build up your dividers, right? So I can choose either one of them will be a part of your divider, or yeah. And the second one is same. I can choose either 0 or 1 all the way to 3/5. We have a six option to choose your the exponent based on 3, right? So the first I have 11 options, and the second I have 6 options, and the third one I have 3 options, and the next one I have 2, and the last one I have 2. Okay, and that's give you the number of dividers you can pick up. So this is the other part I need you to take away. So first is how you get the factorization of a factorial. The second, the number of dividers, it should be E1 plus 1 times E2 plus 1 times blah, blah, blah. Okay, depending on how many exponents that we have. Okay. So that should give you the number of divisor of giving a polynomial. So with the help of that, this question can be considered as, okay, so the total number we already got should be this way. Will be the denominator, 11 times 6 times 3 times 2 times 2. Okay, so you need to pick up the divisors is a perfect square. So think about the perfect square. So for instance, 2 square is a perfect square, but 2 to the power 3 is not a perfect square. So the index of the power index must be an even number. So in that way, if you go back to the check the factorization of your 12 factorial. Yeah, unlike the yellow one. Okay. So I can see that I can choose 2, 5. That is a power. We can have a square, and this one 3 square times 5 square times 7. Well, 7, 11. That is it just to the power 1, right? So let's have a 3 here. So this part we cannot make them a perfect square, right? So the only possible is this. I have a 2, 5 times 3 square times 5 square. So if you're choosing the dividers of the value in the parentheses, that can make you a perfect square. Okay, how many divisor of these values? Well, similarly, we have a 5 plus 1 times 2 plus 1 times 1 plus 1. Okay. This should give you the value of 1 over 22. And you want to sum them up, the answer is E. All right, as the times go really fast, I need to jump to the next topics. Yeah, for the combinatorics, for the counting problem, let's try a few of selective counting problem. Yeah, let's try this one. This is number 18 in AMC A. So we have a 4 orders number, and that's not necessary to be distinct. And all of that is integer and have to choose from the set 0, 1, 2, 3. For how many of such of quadruples it is true that A times D, or is the product of the first and last one, minus the product of the two in the middle, is an odd. To give you examples, of 0 times 1, the first and last is 0, minus the product of the middle two, 3, so -3 is an odd. Okay, so for the counting problem, so there's a general or a systematic way to count without repetitions or missing. Okay, like this one. We generally speaking, if in all the cases we do the casework, right? So if all the cases is symmetric, so we can reduce that based on the property of symmetry. And also, if it's we can reduce the big problem into a different cases. Like say we can separate into case 1, case 2, case 3, and we narrow down and we work on the different cases, and that can make this question a little bit easier, right? So like this one, first of all, A, B, C, D can only choose from 0, 1, 2, 3. Okay, and the difference of the product is an odd. Well, how can you make the difference as the odd? There's only have two options, right? So they can be either odd minus even, or even minus odd, right? So this is only two ways. I cannot do even minus even or odd minus odd. So the result has to be even, right? So then is the problem, like how can I choose the options to make that, like say A times D as an odd? Okay, so in this case, we can, okay, so there only have two options, right? Odd to A and D chose as an odd. So it will be both of them are odd. Okay, so A can be odd. We have two options, right? So this is A. And D has to be odd. We have also two options, right? Okay, and even, think about even. How many ways we can make an even? So for that case, I can have either even time, like even time even, or even time odd, or odd time even. Only we cannot make odd time odd. So for the selection of B and C, so in that case, so the first one, they can be even and even, right? So I have a two case. So here also two case, right? And this one is 2 by 2 as well, and this is 2 by 2, right? So so in that case, I need to sum them up instead of product, because I can just kind of or. So for the options of B times C can be either even time even, or even time odd, or odd time even. So in that case, I need to sum them up. So that would be the total options that B times C can choose, which is 12, right? Okay, and then since for the first situations, odd, the first part, I have 4 different way I can select it. And the second, even, I have 12 way I can select it. So this is actually step-by-step case. So I need to do them multiplication. So that give you 48. Okay, and also you need to distinguish the different one. I need addition and subtractions. Like I just repeat that, like this part, if it is the or in between the cases, we need to consider just sum them up. But if it's and, so like this case, so the first part A times D must be odd, and the B times C must be even at the same time, right? So this is and situations. So I need to using the the product. So I have a 48 options for the first. Do we need to worry about the second? No, because it's totally symmetric, right? So you can just repeat it. So there's no difference. So there should be another 48 in the second. You can see that using the symmetries that actually can reduce your hoverboard. So in that way, totally 96. Okay, let's try one more. Make it briefly for this counting problem. Okay, so we have a figures is dedicated hadrons. So just like a picture is like that. So each surface is the pentagons. So totally they have a 12 is congruent regular pentagons. And so we want to start from the top pentagons and go through the, they told you they have a two type of ring. So say there's a ring of 5 slanted faces adjacent to the top surface. So we consider like this run, I will call, this is the top, and this is like kind of A, B, C, D, E. I can picture that this is like a top ring. So I'll call this upper ring. And similarly on the bottom, this is the lower ring. And also we have a very bottom surface, bottom face pointing down, right? I give you a different name. So how many ways, there's also another counting problem. How many ways are there to move from the top face to the bottom face with a sequence of adjacent faces so that each face is weighted at most once and the move not permitted from the bottom to the top. So so based on that, it can only from the top to the bottom, it cannot go backward, right? So based on that, we need to like nail down the problem if this problem is kind of challenging to you. So they want to find out how many ways, like what? So need to walk from the top to the upper ring and to the lower ring and finally to the bottom, right? They cannot go backward, so there's a single direction. But if you study on that a little bit, you can find out, okay, I can wander around this range. For instance, I can go from the top to the face A, and then I can go to the B, and then I jump from B to the lower ring, right? Or I can just go to A, and I can move to E and D or C or B and back to A, also possible, right? And then I move to lower ring. So they may have a lot of options in between of that. So we need to count this. So, well, if you count separately, so this part from the top to the upper ring, so since they have 5 different faces, right? So they actually have 5 options. And on the upper rings, so you can either stay on A, or you can do wandering from A to B, or you can continue in that direction, A, B, C, D, or just go to E, right? Yeah. Or you can change direction, as I mentioned, you can just go from A to E, and A, E, B, or all the way. So you can find out in the upper ring, if you're wandering in that level, in the same level, you have totally 9 options to go. Okay, and from upper ring to lower ring, actually you if you finish the wandering in the same ring in the same level, you can just dig into it, right? So there's no way you can just jump from the upper ring to the lower ring. And around similarly, you can see this is kind of symmetric. So since we got 9 options for the upper ring, so the points the pointer can also wandering around the lower ring, so that actually have a 9 options to go. Okay. Yeah, and well, actually here it should be 2. Think about that. If you finish that, finish the wandering in the same ring, let's say when you need to jump from A to the lower ring, so you can either jump here, right, or you can jump to the right. So this, for each case, they actually have 2 options to go to jump from the lower ring to the from the upper ring to the lower ring. Hopefully I make this clear. So in between upper ring to lower ring, just like very basic cases for just stay A, no wandering. So from top to A, right, you can go either to the left or you can go to the right, right? So you have 2 options. Similarly to, let's say, AB, I can from top to A, and then I move to B. Okay, just a better change to another color. From A to B. And at this B, the face of B, you still have 2 options. You can either go to the left or go to the right of the lower ring. So for each way, but obviously we don't consider about the horizontal, because horizontal we will consider is inside of the level, the same level, upper ring level. So we already count that. We don't need to repeat that. Right, and after you're done, so I just continue on that. For the lower ring, after you finish this 9 count, so no matter which phase you are at now, and there's no other option because they only have one bottom phase below that. So this is actually the one mentioned. Okay, so then we just multiply each options by different steps, and this should give you the result. I believe it's E, 8, 10. Okay, I think let's quickly move to the next. It's still combinatorics type of question, but the 2 I showed you is the counting problem. Let's try a couple of the probabilities. Okay, like that. This is a common question in 10A, question number 13 and 10A, and number 11 and 12A. Okay, we have a flock sitting on the point 1, 2, beginning on the sequence of jump, where each jump is parallel to one of the coordinate axes and have a length of 1, and direction of each jump for directions are chosen independent and random. The sequence end with the frog reach a side of the square. Okay. And what is the possibility that is the sequence of the jump end on the vertical side of the square? Okay, let's draw that on the graph first. So we have, Okay, let's back to work. Okay, we have a point 1. Okay, so this is the starting point of the frog. Okay, and they can be jumped either to the left or to up or either way, right? Okay, so you can go this way, and each time it's just one length of 1. Okay, and they want to know finally what is the probabilities that this frog will be stopped at the vertical side of the square. So either here on the left or here on the right, right? Okay. So, well, let's starting from the easiest case. Also, still be a counting. Let's if the frog is go to the left, how many way? Because they can it said they can choosing direction of jump independently and random. So each one of them have 1/4 chance to be jumped, right? So on the to the left, you can jump to the left. They have 1/4 of chance to jump to the left. So, well, if this one occur, it's happened, they already reached to the vertical side already, right? So yeah, so for this case, we already have 1/4 times 1. So they already success. Okay. For the other case, if you go to the right, okay, so we just go to the center. If you just mark it off the grid. If you go to the center, well, think about if it's located in the center. Also, this is 1/4 chance to go to the right. So they can have 1/2 of chance to stop at vertical or two vertical sides, right? Because we have a two vertical, 2 horizontal. Each one should have a same chance to be stopped, right? So if it's just exactly in the center, so it should be the same. Half and half. For the chances, half and half, right? So for the other case, if you go up or down, think about at this location, so it can go, you can find out this is kind of special because it's located on the diagonal, right? So the point on the diagonal is also symmetric. So to the left or to the up, or say to the right or to the bottom, so it should have the same chance, right? So any point on the diagonal should have even amount of chance to reach to the vertical or horizontal edge, right? So yeah, hopefully that makes sense. So for this part, if it's reached to this diagonal, so they also have a half chance to reach to the vertical, because any starting points from the diagonal, they could have half a chance to reach to the vertical, half a chance to reach to the horizontal because of symmetry. Okay. What if it go down? You can find, this is a point on another diagonals, right? So it should be the same situation. All right. So, well, this is all the cases we can have for this frog. So sum them up. Okay. So should give you the answer of 5/8. So yeah. So for the probability collections, if you let us start on the beginning. I'll try to convert it into a counting problem and consider a case by case. Yeah, usually that can give you some idea to start with. Well, we actually really run out of time. I say, is there any question we need to discuss? Yeah, this is kind of similar questions. Okay, so we have a point, it shows at random with the square in the coordinate plane, whose vertices is 0, 0, 20, 20, 0. Okay, so we have a cube, right? Like this, we have a cube. Yeah, the length of each edge is 20, 20. So probability of the point line within d unit of the lattice point is 1/2. Okay, so this is like a lattice point. So actually, if you're starting from any point, okay, so that will be the lattice point. So it's that like if I choosing a point randomly, so this point is so this point is within the unit of the lattice point is 1/2. Okay, so since each square, the little square, the unit square is totally equally, right? So the big square, every one of the unit square inside should have an equal chance. So let's reduce this to a small case. Well, actually, this is exactly the same. I just changed the scales. I say this is 1 and 1, right? Consider that this is just the point we discussed in the one specific grid, right? And they have a 4 lattice point around this, right? So this is 1, this is 1, this is 1, this is 1, right? So we have a point here. Okay, so this point lying in D unit of the lattice point is 1/2. Okay, so this will be considered as a geometric probability expression, right? Think about it. If we have this is the distance, right? So if this distance less than within D unit, so how you describe the point have a D unit away from this vertex? So what we need to do is just draw a circle here. So any point in that, let's say if it's the radius D, any point inside of this a quarter of circle should have a distance like D unit within the D unit away from this point, right? Similarly, for the other 3 vertexes, I can do in the similar way, right? Yeah. So now, if you're choosing a point from this shaded area, right? If I choosing a point like each a quarter circle have a radius d. So in that case, if I choosing a point in that area, so it should satisfy the point within the unit away from a lattice point. Okay, and the next is just okay. The area of that shaded part over the total square should be 1/2. Okay, so this is actually the question asked you about. So we just find out the pi e squared and over 4, that 4 of them, so the area of the shaded part divided by the total amount, which is 1. So that should be 1/2, and that should give you the yeah. We need to find out approximate value for b, and in this case is I believe it's It's B. Yeah, it's B. Yeah. Okay. Let me check. Let's maybe do one more. Okay, that'll be the last question here in the probabilities. And the next will be some question. It will be like a 12 only, AMC 12 onlys. I just go through that pretty fast. So you can see that you can have a trigonometry questions like this one. So, well, for this specific question, you just need to try to using the graph of the trig function to find out the how many solutions or how many intersections. Well, yeah, and this is a 12 only. So if you are going to take 10b, so supposedly there's no fraction related to the trigonometry functions. Okay, and this is a question about the logarithm, right? Logarithm functions, right? So we need to using the property of logarithm, right? So there's a base change formulas and the property for the logs. That is, yeah. So you just go back to recap of that. Should be pretty useful. So like this is a log equations, right? So obviously we need to make the base the same, and then we can continue on that, right? So like this one, so log based on 4, so we can rewrite that into yeah, like this one. Just make it quick. So this one should be considered as convert the 2 log on the both sides the same base over, and we know that is 2. Okay, and then I move that to the other side, and then we're using the property for the log and rewrite this into log 2 log based on 16 now and square of that. Okay, so we have this is a double log, and we change into log of square, right? So this is a property for log. So you just need to recap. Yeah, and then we can just get what's inside of the log equals, and then you can just continue on that. It should give you the result. Okay. Okay. All right. Let's try another one. That'll be okay. Some complex numbers, right? Like this questions. So in the complex plane, A will be the set of solution of z's cubed minus a equal to 0, and let B be the set of solution of the other one. So what is the greatest distance between the points? So yeah, so for the complex number like this, let me using a minute to discuss that. So starting from z cubed minus 8, we can list all the solutions on the complex number planes, right? So that should relate it to like a circles, center and regions, and have a radius of 2, right? So this point will be one solution, and that actually lead to the vertexes of this equilateral triangles, right? Each of those vertices give you the solutions, right? So we actually learned that in the pre-calculus process, right? And this point, if you figure it out, that should be negative 1 plus root of 3i, and this is just 2 plus 0i, and this is minus 1 minus root of 3i, right? Something like that. And the next one, we need to find out solution for the second equation. So zq minus 8z squared minus 8z plus 64 equal to 0. And this one actually can be factored by that. So z squared minus 8 equal to 0. Okay, so obviously we have a solution of 8, right? So that will be one root, should be located somewhere here. And this part, z squared minus 8. So if you solve that, that should be relative to, well, obviously plus or minus root of 2, 2 root of 2, right? Yeah, so that has to be marketed on the real number line. So they want to find out what is the greatest distance between the point of that 3 to the point of that 3, right? Obviously, so this is the farthest distance from this point to the 8, 0, right? Yeah, and then just using the distance formula to figure this out. Yeah, we can find out. This question is number 15 on the 12A. Supposedly, if you are familiar with the complex number, it's doable, definitely, right? So, but you like this one and the previous question, the log functions. If you still have some times tonight and tomorrow, just go back to recap the properties for the rules of logarithm. Logarithmic functions and the complex number, the solution of the complex numbers that might help you if you need to take the 12B. Okay. All right. Yeah. There's yeah, lastly, if you have some questions related to the course today, we have the WeChat groups, so you can scan this QR code, yeah, so before the B days, right? So 10B or 12B, we try to reach out to help you. And also, we will reach you if you need the copy of today's the slide. Well, just scan this QR code and we'll reach you out. And also, for IvyMax, we are the official the AMC test centers. So if you don't have if you want to register on the AMC tests on the B days, but you don't have a chance to go with your schools, so I believe we still have some of the limited spot in the different learning centers. So try to reach out to the center. Maybe you still have a chance tomorrow to register on the test. Okay. Thank you for your time. Yes, today we used almost 3 hours to quickly review the questions on the 10A and 12As. Hopefully that will help you to prepare the B days test. Okay, let's use another minute if we can answer some questions here. We were recording of this webinar. Yes, as I mentioned that if you scan the QR code and request that, I believe we can pass that to you. All right. Thank you, everyone. Thank you for your time. Hopefully, you will score well in the B days, and will be invited to the Amy round. Thank you so much.